Jai Hind. I, Prashant Tripathi, Assistant Professor in Electronics and Communication Engineering Department at Ajay Kumar Garg Engineering College, going to present a topic which is based on frequency reuse. So, in this topic, the contents are, in this presentation, the contents are introduction, cell theory, frequency reuse, channel strategy, and interference and system capacity, and last is references. So, when we talk about wireless communication, the first question arises in our mind, what is wireless communication? So, the transfer of information from one place to another place is known as communication. When this communication uses no physical wire, then it is known as wireless communication. Wireless communication has entirely changed the way how we connect, communicate, and conduct business in today's digital life. The convenience of wireless technology and its ubiquity feature have led to its widespread adoption across various sectors. As our world becomes more interconnected, a demand of efficient and reliable wireless communication continues to rise. As this demand increases, more number of subscribers are going to add in our wireless communication system, which we are using in every field of life, whether it may be our remote control, our mobile phone, in all field, the wireless communication is introducing very increasingly. Due to increase in number of subscribers, there is a problem of spectrum congestion, delay, and prior to introduction of cell theory in wireless communication, the spectral congestion and delay was a significant problem in wireless communication system. But introduction of cellular technology, cellular concept was a significant breakthrough which developed efficient and highly reliable wireless communication system. The cellular concept has the potential to solve the spectral congestion and increases the capacity of wireless communication system. In cellular concept, basically the entire coverage region in which we want to provide the communication is divided into a small geographical region which is known as cell. In this cellular theory, we have multiple choice for cell shape, like we have circular, triangular, square cell, and hexagonal cell. Each shape has its advantages and disadvantages, and based on some advantages, we have selected hexagonal shape. Hexagonal shape is selected due to its ability to provide uniform distribution. It has capability that there is no overlap between the cells and it covers entire region without any gap. Apart from these advantages, the hexagonal cell is also useful because it makes the analysis of wireless communication system easy. Other advantages is lesser fading at the edge of hexagonal cells. These are the different fading is lesser as compared to other existing shapes. When we use a hexagonal shape, other advantage of this shape is we can install the antenna at the center of this hexagonal cell or at the edges of the 6 cell vertices. When the antenna is placed at the center of hexagonal shape, it is known as central excited cell, and when we uses the edge of hexagonal shape, it is known as edge excited cell. For central excited cell, we uses omnidirectional antenna, while for edge excited cell, we use sector directional antenna. As I have shown these antennas, placement of these antennas in this particular slide. The antennas are placed at the edges of these vertices, and it is highly directional antenna because our aim is to provide a particular coverage in this edge excited cell. While when we talk about center excited cell, the antenna is placed at the center of this hexagonal shape. So, due to these advantages, we have selected the hexagonal shape in cellular theory to cover the entire region for providing the communication between different subscribers. As I told you that the cellular theory was a major breakthrough to solve the problem of spectral congestion. Apart from this point, we also know that in any communication system, transmitted power and frequency bandwidth is two primary resources which we must use optimally. So, with the help of cellular theory, a concept frequency reuse is introduced which optimally utilize the frequency range available to serve the various subscriber. So, frequency reuse was a major advantage of cell theory. Basically, the design process of selecting and allocating channel groups for all the cellular base station within a system is called frequency reuse or frequency planning. This concept enables us to use the same frequency range for different region which is attached to a serving region. In this frequency reuse concept, each cellular base station is allocated a group of radio channels which is used within a small geographical area, which earlier I told you that this area is known as cell. So, in each cell, we assign a different group of radio channels. The cells which are adjacent to base station are assigned the channel groups which are entirely different from neighboring cells. Now, the question arises, when we assign different channel to neighboring cells, there is also a possibility of interference. So, to avoid this problem, we use antennas and limit their radiation in such a way that they can only provide service to the region for which they are intended. As I have drawn in this particular slide, we have divided this entire region into small hexagonal shapes, and this hexagonal shape, the A, B, C, D, E, F, G, these hexagonal cells are allocated different frequency for the transmission. Now, the same concept, by using frequency reuse concept, we can assign hexagonal cell which are far apart from the original one. For example, this cell A, in this cell we have assigned a frequency range For example, the same frequency range is also can be assigned into this hexagonal cell, and it is represented by A. Now, the main and important thing is, while assigning same frequency range in hexagonal shape, we must keep into mind that the distance between these two cells must be at proper distance, so that the both stations do not interfere with each other. This concept is known as frequency reuse concept. The collection of n hexagonal cell in which the entire frequency range is divided is known as cluster. So, in this example, there are 7 cells in which all the available frequency spectrum is divided. Now, by repetition of all these cells or cluster, we can serve any number of users which want to communicate. The minimum distance between the two cells which are using the same set of frequency is known as frequency reuse distance, and as I told you, this distance must be in such a way that the interference will be very low or minimum. Now, let us assume that we have a total of S duplex channel, and this S duplex channel is divided into a cluster. We have divided this S duplex channel equally in each cell which is present in the cluster. For example, I have assumed that there are n cells in the cluster and each cell has k channels. Then obviously the total number of available radio channel in the cluster will be S equals to k into n. Now, to increase the capacity or number of subscriber, we can replicate the cluster by n times. Then the total number of duplex channel represent the system capacity, and it is simply given by C, represented by C, and this is equals to M into S. As earlier we have seen that S is product of K into N, where K is the allocated frequency to each cell and N is number of cells in a cluster. So, by increasing the cluster, we can directly increase the capacity of communication system. If we increase M, then capacity will directly increase. Factor N is called cluster size. Suppose we have the total number of channel allocated for a cluster is 395, which means the entire available channel is divided into 7 hexagonal cells. So, each cell has 57 frequencies to serve the subscriber. The factor 1 by n is known as frequency reuse factor, and within it, and it represents the quantity which is assigned to each cell, and this cluster size is given by n, and this n equals to I square plus j square plus I into j, where I and j are non-negative integer. For example, if we take I equals to 1 and j equals to 1, then the value of n will be one square plus 1 square plus 1 into 1, that is 3. Another example, suppose I equals to 2 and j equals to 3, then n will become 4 plus 9 plus 6, and this will be equal to 19. So in a cluster there are 19 hexagonal cells. The possible values of n are 1, 3, 4, 7, 9, 12, 13, 16 and 19. Here, when we assign same frequency to another cell which is physically separated from the original one, that cell is known as co-channel cell. It means the cell which are using same range of frequency is known as co-channel cell. There is a way to find the co-channel cells, and to find co-channel we use I and j. The value of I represent the cells along any chain of hexagonal, and j represent how many cells we have to travel while turning 60-degree counterclockwise. For example, if I take I equals to 3 and j equals to 2, then first I will travel 3 cells in direction of any hexagonal cell. So for example, if I choose this hexagonal cell direction, then I will move 3 hexagonal cell, 1, 2 and 3 counterclockwise, and move 2 hexagonal shape because j equals to 2. So when I move this in this direction, I will reach to this hexagonal cell, and this hexagonal cell is known as co-channel cell. In similar manner, if I choose this hexagonal chain, then I will move in this direction by 3 hexagonal cell and turn counterclockwise by 60 degree and move to 2 hexagonal cell, and I will reach this cell which is the co-channel cell of this particular A cell. So using this concept, we can easily find the co-channels in our wireless communication system. Now, the use of frequency, the application of frequency reuse is also applicable in channel assignment strategy. And this channel assignment strategy is divided into 2 parts. One is known as fixed channel assignment and another is known as dynamic channel assignment. In fixed channel assignment, the entire channel is allocated for voice transmission. Each cell is allocated a predetermined voice channels. Whether cell use this channel or not, but this channel will always present to that cell. So if there was a lack of efficiency, suppose my cell is not using any conversation, any call, then our channel will be unutilized, and this is the wasting of resources. So to remove these drawbacks of fixed channel assignment, we develop another assignment strategy which is known as dynamic channel assignment. In dynamic channel assignment, the voice channels are not allocated to different cells permanently, but they are available at a request basis. Each time every subscriber, if a subscriber want to make a call, then request is made to serving station for the voice channel, and the base station transfer this request to mobile switching center. Mobile switching center, after analyzing the various factors which I have listed here, provide the voice channel to the subscriber. The algorithm which takes into these points, on the basis of these points, mobile switching center provides the voice channel to the subscriber. These points are likelihood of future blocking within a cell, frequency of use of the candidate channel, reuse distance of the channel, cost function, real-time data channel occupancy, traffic distribution, radio signal strength indicator of all channel on a continuous basis. By taking these points into consideration, the mobile switching center provides voice channel to a subscriber which demands for it. The dynamic channel assignment strategy has basically reduces the blocking probability, but it increases the load on mobile switching center. But at the same time, it reduces the blocking probability and also it enhances the channel utilization. Now, when we talk about frequency reuse, the important factor is interference and system capacity. So, what is interference? Interference, when our desired signal get interrupted with unwanted signal, that is known as interference, and the consequences of interference may be severe. If the interfering signal strength is very much greater than the desired one, our system cannot recognize the transmitted information, and the receiver which want to listen the desired signal may be confused or may get some distorted information. So, interference is an important factor which we must keep into our mind while designing wireless communication system and using the concept of frequency reuse. Also, it influences the system capacity, because if interference is large, then obviously it affects the system capacity, which is basically also reduces the number of subscribers which are using system simultaneously. In wireless communication system, there are various sources of interference, like another mobile which is transmitting in the same cell. Also, a call which is going in the neighboring cell may interfere the desired call. Other base stations which are operating in same frequency band can also affect the transmission. Apart from these interferences, the different kind of inadvertently leaks energy also may interfere our desired transmission. The interference effect are basically appear in the form of crosstalk, where a subscriber can hear background noise, some kind of undesired transmission. Also, if the interference is present, it may affect the control channels, and when the control channel are disturbed, the subscriber may experience missed or blocked calls. So, interference must be minimized and it should be as low as possible while designing the system. When we talk about interference, the cells which are using, and this co-channel interference must be very small to provide an efficient transmission. Like thermal noise, we can't decrease or overcome co-channel interference, because if we increase the signal to noise ratio of transmitted signal, then the other co-channel cell power will also increase and they affect each other. So we can't use enhancing of signal to noise ratio to overcome the co-channel interference. The one possible way to reduce the co-channel interference is we should place the co-channels to a distance which is sufficient to provide minimum interference. So, when we provide sufficient distance, the co-channel interference is minimum, and by using these points we can effectively use frequency reuse concept to enhance the number of subscriber in a particular region, and we can efficiently utilize the frequency which is available to us for serving a large number of subscribers. So frequency reuse concept is very important concept, and it is the basically that concept which enables us to enhance the number of subscriber in a wireless communication system and system capacity. So these are the reference and books which I have used to while preparing these slides. Thank you.